Alright, welcome to this episode. Today we're going to be going over quotient rule, as you can see on the screen. And this is four out of the four different ways of solving the derivative. And this is a pretty useful rule. It's pretty solid. So what we could do is we have p of x here. So p prime of x is equal to g of x times f prime of x minus f of x times g prime of x over g of x squared. And so something that's very important to keep in mind is that um, the numerator's order is very important because we're subtracting, right? For product rule, it doesn't necessarily matter because we're just adding, so it's not really that important. But when you're subtracting, it makes a difference, right? And so what we need to do is keep in mind that it's g of x times f prime of x, and not the other way around. And so I'm going to try an example I found off some website, and so it's going to be I'll do a different function name. I'll do that's not C, why does it do that? That didn't even look like a 0, or an O, or whatever. C of x is equal to x squared over 3x minus 1. And so the top function is referred to as f of x, and the bottom function is referred to as g of x. And so we can, or I should say the numerator, not the top and bottom. It's kind of elementary. And then we have f of x equals x squared, because the numerator is equal to f of x, and g of x is equal to 3x minus 1, because the numerator is always equal to g of x. And now we're going to have f prime of x, which by power rule we know is 2x, and g prime of x by power rule we know is 3. And so now let's construct, we have all the information we need to construct the non-simplified version of our derivative. And so let's say c prime of x is going to equal, so g of x, which g of x is equal to 3x minus 1 times f prime of x, which we know is equal to 2x. And then we do minus f of x, which we know is x squared. Put brackets around it because why not? And then times g prime of x, which is going to equal to 3, yeah, just 3. And now we have our numerator, right? And so now we need to go over g of x, which is 3x minus 1 squared. So now this is our derivative. It's kind of ugly, looks like shit, but we can simplify it and make it a lot nicer. So what we're going to do is let's go ahead and simplify the numerator and the denominator and see what happens. So c of x equals 6x squared minus 2x, because if we look, 2x times 3x is 6x squared, and 2x times negative 1 is negative 2x. Gonna get rid of both of those lines. And now we have minus x squared times 3, so that's going to be 3x squared. And we do have like terms in the numerator, which kind of makes things nice. And then in the bottom, we have 3x minus 1 squared. And so let's go ahead and, it doesn't even look like an O. Maybe it does, maybe my handwriting's that garbage. C prime of x is going to be equal to, so what's 6x squared minus 3x squared? Well, that's going to be 3x squared minus 2x, and that's going to be over, that could have been written a lot nicer. So we're going to have 3x squared minus 2x, and that's going to be over 3x minus 1, not plus, minus 1 squared. So I'm just going to verify that I did that right, which I'm pretty sure I did. Um, Yeah, so yeah, I mean, yeah, that's the right answer. Um, on the website, the answer key says that you can also write it such that x times 3x and then over what we already have on the bottom, which is just 3x minus 1 squared. And so that's essentially the quotient rule. All you really have to remember is that f prime comes first. It's f prime minus f of x, because you already know that you're multiplying by the opposite function's main function, not derivative. And so that's essentially the quotient rule, and now we have the derivative of c. So we recall that c of x is equal to x squared over 3x minus 1, and the c prime is equal to 3x squared minus 2x over 3x minus 1 squared.